Hello, now for video 4 on gravitational fields. Here we're using Newton's laws of gravitation to find an equation for gravitational field strength. But what is gravitational field strength? It's just a way of comparing how strong a field is by seeing what force it would create on a 1 kilogram test mass. Okay, so gravitational field strength is our value of G as the force per unit mass. Now, force due to gravity varies for different objects depending on their mass. Here, your tank or any large object is going to have a far bigger force than a small object because their masses are different. So if we want to compare the strength of two gravitational fields, we need to use the same mass. So for simple maths, we set that as 1 kilogram. That's our test mass. So, what does that do with our Newton's law of gravitation? If we know Newton's law of gravitation, the force due to gravity equals gmm over r squared, as defined in the last video. We're now saying we're going to set one of these masses at 1 kilogram. Okay? Which gives us gravitational field strength is gm over r squared. Same symbol we use for gravitational field strength, and using the correct data for Earth, you still get 9.81 newtons per kilogram on the Earth's surface. You can test this information using information from the datasheet. Okay, if you want to pause the video and have a play with that now, you feel free. Right. An alternative way of looking at that. Okay, we've come across a weight as mg already, but we know the force due to gravity is also weight, so we can set these two formulas equal to each other. Okay, we want to find g, gravitational field strength. Basically it would mean we'd have to divide both sides by m. That gives us g equals gm m over r squared m, and the m's cancel, which then gives us the same equation that we just found, g equals gm over r squared. So two different ways of finding the same equation. Now, you need to be able to calculate with that, use that equation. So here, an example for you. Imagine the International Space Station orbits the Earth at 408 kilometers. Find the gravitational field strength. Okay, there's your formula, gm over r squared. And again, pause the video, have a go at calculating it, see whether you end up in the same place. Okay, first of all, the radius of the orbit is not just 408 kilometers. You also have to add on the radius of the Earth to give r equal to 6.78 times 10 to the 6 meters. That's the only complication here. That then substitutes into here. Mass of the Earth you can find on your datasheet, g you can find on the datasheet, or the gravitational constant, and then that should give you the field strength at 408 kilometers above the Earth's surface. So put the numbers in, gravitational constant, mass of the Earth, the height we calculated squared, and then calculate out, and you get g equals 8.67 newtons per kilogram. So, last skill you need to be able to do is to sketch a graph of gravitational field strength against the radius. Okay, know how g varies with distance from the centre of the Earth. So, gravitational field strength on this axis, distance on this axis. It's only a sketch, so we want to keep this as general as possible. R is your initial distance, normally the surface of a planet. G would be the field strength on that planet. As you go above that planet, this is going to decrease. But how does it vary? So, you can put your first cross on though, knowing that G at the surface of that planet, G at R. Okay, so you're always going to start up in the top left and decrease from there. Now, because it's a 1 over r squared rule, you know as you double the distance from r to 2r, then this will decrease by a factor of 4. So it becomes g over 4, or a quarter of the original value. If you double it again from 2r to 4r, it'll factor it down by a factor of 4 again, and 1/16 of the original value. Okay, and so on. And then you just have to join with a smooth curve. Okay. Now, next thing we need to do with these videos, we've done gravitational field strength, we can then start looking at a new concept called gravitational potential in the next video. See you then.